Now regarding F block elements also, that is 4F series and 5F series, you should have a thorough idea about the electronic configuration which we mentioned earlier. That is, then just like D block elements, you must have an idea about the properties of this F block elements also. 1. Atomic and ionic radii. It is observed that on moving from cerium to lutetium, the size of the atoms and the ions decreases regularly. The reason is that decreasing, of course, the nuclear charge increases. After that, if there is no change, comes only this shielding effect or screening effect comes about. Lanthanide contraction. When one moves from cerium to lutetium, the nuclear charge increases with the atomic number and the electrons are added in the inner 4f orbital. The shielding effect increases with the nuclear charge, resulting in the contraction of size. This is known as lanthanide contraction. Now, oxidation state. The most common oxidation states of lanthanoids is +3. Besides this state, lanthanoids also exist in +2 and +4 oxidation states. The most common oxidation states by actinoids, that is, lanthanoids and actinoids together constitute F block elements. Then actinoids is +3. Besides the oxidation state +3, actinoids also exhibit +2 and +4, +5, +6, +7 oxidation state. The ionic radii of actinoids decreases regularly across the series. That is due to the increase in the atomic number and the nuclear charge. The phenomenon is very much similar to the lanthanide contraction. Then, as a result of the increase, the nuclear charge increases. The size of the atom becomes reduced. But once the screening effect comes or shielding effect comes, there is not much difference. This is due to the shielding effect. That is, then next is color of ion. Except a few exceptions of the tripositive ions of lanthanoids are colored. They show color in the solid state as well as in the aqueous solution. Most of the actinoids are colored. The ions having 5F0, 5F1 and 5F7 are colorless, while those having 5F2, 5F3, 5F4, 5F5, 5F6 are usually colored. Choose the correct answer. That type of questions can be asked from that section. Formation of complexes. As compared to the D block transition elements, lanthanoids form only few complexes and less readily. The reluctance of lanthanoids to form complexes is due to the following two reasons. 1. The size of the tripositive lanthanoid cations are large as compared to the transition elements. 2. In lanthanoid ion, F orbitals are not available to form a hybrid orbitals, which leads to the covalent bond strength. In the absence of the availability of the F orbital, the chances of the complex formation becomes less. If there is no available F orbital, then there is no chance of forming complexes. Chemical reactivity. Due to the similar outer electronic configuration, the existence in mainly +3 oxidation state, lanthanoids show very similar chemical properties. The lanthanoids are highly electropositive and highly reactive elements, as is evident from the following properties. On exposure to air, lanthanoids get tarnished readily, resulting in the fading of the silver white luster. 2. They burn in air and form their respective oxides. 3. They react with hydrogen to form non-stoichiometric hydrides. 4. They react with nitrogen or warming. It forms corresponding nitrides. 5. They react with nonmetals like halogen, sulfur, carbon, etc. to form corresponding compounds. 6. They dissolve readily in warm water to liberate hydrogen.